of introducing the keynote speaker, Anna, the CEO of Instrumental. As I mentioned earlier, we've had the privilege of working with Instrumental since their very first days. And Anna will be talking about what data as infrastructure means and frankly, how we could all be using our manufacturing data to run our lines better. Writing an introduction for Anna was frankly the easiest thing ever. In fact, all I had to do was start removing stuff to fit the time. Anna holds 2 mechanical engineering degrees from Stanford. She cut her teeth at this little electronics boutique you may have heard of called Apple, where she led system product design for the Apple Watch and worked on several generations of iPods. I mentioned earlier that my day job at Root Ventures invests in engineering tools. And if I could find like 3 or 4 more people like Anna, my job would be so much easier. And so without further ado, Anna.
Hi, everyone. Welcome to Build Better 2022. I'm so excited to have everyone here. We have engineering and operations leaders from around the world dialing in today to learn tactics and best practices. And so I'm just so grateful for the speakers that we have and also for those who have come to share what they know. So let's dive into today. My name is Anna. I'm CEO and one of the founders of Instrumental. As a little bit of history on Build Better, this is our 3rd Build Better. I found that there weren't a lot of places for engineering and operations leaders to talk to each other about best practices. They're kind of siloed within their companies. And when we asked them, where do you find out about new technologies? Where do you find out about new techniques? They said they would just call up their old coworkers. And so that's going to be a very slow way for this industry to build up together. And so we had our first Build Better in February of 2020, where we got a bunch of people together in Palo Alto to actually start having these conversations. Since then, last year in 2021, we did it again. And, the period of time between the first and the second was a dramatic one for our industry when everybody was trying to figure out how to keep going during the pandemic. Factory lines were down, people couldn't travel, how they're going to get data, how they're going to get prototypes, how they're going to ship products on time for their companies. And so it was an amazing opportunity to kind of share those tactics we'd all learned together over that last year. And this year's event I view as kind of as we start to hopefully be moving into a different phase of the pandemic. I'm really excited to kind of see that story arc continue. And I really encourage everybody to spend some time today in our breakout sessions sharing your tactics and best practices that you've learned, because ultimately this industry is in transition and there's a lot going on. And so if we're just calling up our old coworkers one-on-one and that's the way we're sharing information, it's not going to be fast enough. So we hope that venues like this can create opportunities for that. And that's why we run Build Better. This is a passion initiative here at Instrumental for leaders that matter, because we all care about building better products. So let's maybe reflect a little bit on the state of the industry here in 2022. We're kind of coming out of this pandemic phase where we spent a lot of time just adjusting our products. For the first time, we were actually, as an industry, building products based on the chips we could get, making changes in between builds based on what parts were available and what we could build. We had to solve problems of how to actually get engineers access to physical prototypes when a lot of travel was very difficult, and how we're gonna learn as engineers about the products that we're building in development and also the problems that we're facing in production. And we also saw during this phase a lot of plugging in. And so we saw companies and leaders identifying data that was latent in their process, meaning they were already collecting it somewhere. It just wasn't really plugged into systems that others could get. And so we saw this trend towards plugging in, and it's really created some interesting momentum as we now look forward to what's next. And so ultimately, the experience of plugging into that data has really led to data-centric workflows that didn't really exist before the pandemic, because we really spent a lot of time flying around and doing things a little bit more analog. And now those workflows, we're actually realizing we can accelerate discovery by as much as 10x in terms of speed, which is amazing. And we've also been able to show that we can use these data-centric workflows to actually pinpoint opportunities for process and design design improvements. And so we don't need to necessarily be as connected to we don't have to physically be in the factory to still be very connected to what's going on and how we as engineers and operations folks can push these products forward and make them better. And so that really leads us to the theme of this year's Build Better, which is manufacturing data is infrastructure. And I'm going to talk a little bit more about what that means and peel it apart, but it's ultimately about kind of moving this trend that is happening, this change that's happening in manufacturing as we move away from using data as a tool where we're very judicious about and pinpointing and targeted to viewing data as something that we want to grab from all the places we can reasonably get it and actually mine and extract for information. And I think what's really fascinating about this is it's not really technology for technology's sake. There's actual improvement in the process and the core metrics that leaders care about because they're making these movements towards data as infrastructure. So I'm really excited to kind of share about what we're learning and our customers are learning and the overall industry is learning about manufacturing data. And that was the inspiration for this year's curated theme. So if we want to kind of look in the greater context of technology overall, I think there's a really interesting analogy to what software engineering was like 15 years ago. And so I'm not a software engineer, but I did validate this with a bona fide software engineer that this analogy makes sense. But 15 years ago, when software engineers wanted to understand how their servers were running or the apps on those servers, or even to get access to their logs and metrics, they had to go manually collate this data. They wrote scripts to do it, but they still had to go get it from a bunch of different places. And if you would do that now, it would be seen as heretical because in the last 15 years, there's been a slew of companies who have done that kind of pre-processing. The value in building data as infrastructure is absolutely enormous in software. And if a software engineer shows up to a company and they don't have some of these basic tools, they'll just leave. Like you don't do software without these kinds of basic tools. And so maybe it's just me, but when I look at that stack up, I see a lot of parallels to what we do in manufacturing. Instead of servers in a cage, we've got factories, we've got physical things happening in places distributed around the world. Instead of apps running on them, we have the products we're building, the units, the product lines, physical devices. And then we also have our own version of logs and metrics. We might have fancy names like traceability or telemetry, but it's the same stuff. But unlike software, we have this extra piece that makes it hard mode, which is the supply chain part. And really this stack up exists multiple times over and over throughout the supply chain. So not only do you have one of these stacks, you have many, maybe 50, maybe 100, depending on your product. And that's crazy. This is absolutely way harder of a problem and way more necessary than software and the problem that was solved in software. And so we really need a solution for this in getting this data from all of these different places. And engineers know this too. We recently did a survey, so the results will be published soon, but this is a state of mass production survey from this year, and 63% of teams are actually relying still on manually compiled reports as their main data source. So this is manually compiled generally by factory partners, emailed over, that's where they're getting their data. And 2 in 3 teams aren't satisfied with the access they have. So there's a clear demand and need for better data. We're essentially where software was 15 years ago. And so of all the data that would be reasonably able to be collected, generally about 3% actually is, and less than 1% is actually used. And the core reason for that is because we're in a transition from a kind of an old way of thinking about data to the new way of thinking about data. So the old way is thinking about data as a tool. What does that mean? Well, it means that data, it comes from this mindset that data is expensive. It's not, but it comes from that mindset. And so it needs to be judiciously applied. The one-to-one, we need to measure this so we get this one specific result, and we don't have other ideas for results we need, so we're not going to measure all these other things. So that's data as a tool, as a mindset and approach. The other approach is data as infrastructure, which is much more similar to that kind of software analogy, where it's looking at actually the rule is generally to collect things when it's reasonable. So if the data is being generated, collect it, save it, do something with it. And it's all about making it more and more easy and more reasonable to get that data. And then it's also about how you analyze that data to get the value out of it. And so it's a completely kind of two different approaches that we're in transition for. So this old approach around data as a tool has some major drawbacks. So one being that pre-processing is generally required because the data is often either not there, you're relying on luck that you had the foresight to, oh yeah, we should really measure this thing. And then if you haven't, then you mean to have to ask for it or go get it or do an experiment. And that processing time of even when you get the data, it's in a variety of different formats. You need to get it into your jump instance and figure out what's going on in the data, actually solve problems. And engineers spend 13% of their time on this low value pre-processing work to do discovery in data, which is a big waste. This is more than a month of time every year, 40 something days to be specific, every year that engineers are spending doing that. The second core problem with it is that it really is essentially relying on your more senior folks in the organization to keep memories of the learnings of prior programs, prior experiences. And so there's reliance on tribal knowledge because you don't have an external repository in place where this knowledge and know-how is. And so this is a problem, according to LinkedIn. The stats here don't have the where they're coming from. According to LinkedIn, this is a 2021 result. 13% of tech jobs had a 13% year-over-year turnover for tech jobs in 2021. And actually average tenures are going from 3 years to moving closer to 2 and 1 year, depending on the firm you're in. So relying on tribal knowledge is a big problem. The last piece is that because there's such a one-to-one, we're collecting for a specific purpose, there's really a focus on getting a return on investment from the data, and that can be a little short-sighted and then lead to some underinvestment. So let me give you an example. Let's say we're a blender company, and we build blenders, and we have a field issue, and our engineers go figure out what the field issue is about, and they have an idea. They can figure out how to solve that problem, but it's going to require some expensive testing and expensive data. And the cost of that, they need to weigh it against the cost of the returns. And so if you're going to go do an ROI for this, what we see is that many companies will go and they'll look at the cost of the returns, and they'll count that. That's hard ROI. And then there'll be a whole category of stuff they call soft ROI. And one of those soft ROI items will be, well, our Amazon review rating might go down. And we don't know how much that's going to cost us. We have no idea. So we're going to say it's $0 because we have no other number to put in there. And as a result, it's not being accounted for. And maybe they don't decide to fix the blender. It's too expensive. ROI doesn't take up. However, in reality, those soft ROI elements throughout the organization, there's more than just that example, but it's kind of showing you an example of something really hard to calculate, can have a huge impact. Our friend Andre Newman-Lorick at Ops on Tap says the cost of losing one Amazon star is about 50% of sales. That's based on his experience working with first-gen products that sell through that platform. So to just give you an idea of how big of a thing could be unaccounted for when you think about data as a tool. So let's talk about data as infrastructure. When data is infrastructure, it's the data itself that's empowering daily engineering and operational work. When data is infrastructure, as P2I has incorporated in their organization, they get tons of information from their distributed fleet of equipment throughout their global equipment. They're actually seeing and can measure an efficiency improvement of 3x. So this is a picture of Will, who's an amazing engineer on our team, and having 3 Wills would be awesome. And so just why waste the time of these engineers on things that are less valuable? Kind of another core piece is not relying on that tribal knowledge. So you have an external repository of information you can mine for know-how and intellectual property around how you can explicitly build your product better, and that type of product better than anyone else in the world. If you're Bose or Sonos or Logitech, these are companies that build speakers, and you're going to be the best in the world at that. You have IP in your data that makes you better at that. You just need to go get it. Axon is a company that believes that they use data as infrastructure. And one of the core things they were able to do with that is actually onboard new team members more quickly, completely remotely, while moving factories into 2 different locations and still able to launch on time, which was an amazing feat during the pandemic. And that's because they were leveraging data as a core piece of their organization, and the ability to be able to train up and onboard folks using that know-how from an external repository and not just senior employees. And I think the last one around ROI is that, I think we approach ROI conversations because we have learned from automation that it's expensive, and therefore you gotta justify each cost. Like it's a robot arm, it's a camera system, it's something. And so we have this very much one-to-one kind of calculus that we have this reaction to doing. But that's just because it's what we've been doing for the last decade as a muscle. It's not actually related to the technology itself. We think about data, it has all these knock-on effects and trickle-down effects that are really difficult to understand or categorize, which is the same as many other types of infrastructure purchases that companies make all the time. Think about email or Excel or Jump or your CAD licenses for engineers. You don't think about the ROI of these individual tools. You need these tools to do your best work and build great products. And so that's the difference in mindset between thinking about data as a tool as something you need ROI for versus data as infrastructure, and you're going after what you can reasonably get because there's so much in there that's going to have benefits to the broader organization. And so when you have this data infrastructure where you have the layers of each of these pieces, you're grabbing data from each of these pieces, you can actually start to do something that's pretty amazing, which is that you can build feedback loops throughout your process. There are technologies today that help you do this. Instrumental is one, but there are other technologies that help you do this, build these feedback loops. Engineers are sometimes in the loop, sometimes they're not in the loop. And this is really important because this is where we're creating value off of data as infrastructure. It's not data for data's sake. It's data for feedback loops. And then what I see when I look at this is kind of this inevitable future that I think many people will agree with, which is that when you have these feedback loops running, well, what if we could run those on their own? So I think about autonomous optimization as the ultimate opportunity and future for manufacturing and manufacturing data, the ability to essentially run these feedback loops without needing humans in the loop. And what are the problems we need to solve to get to that place so that you could have software that essentially self-improves the product, self-improves the process, figures out that vendor A plus vendor B works together better than vendor, and vendor C and D are the best ones to put together. Which combinations? All of these things are solvable problems once you start to be able to build these feedback loops. And that's ultimately the vision of Instrumental and why I started this company about 7 years ago today. It's the core motivation for me was that I felt it was too hard to find and fix issues in manufacturing. And there was an opportunity to build software that could not only help engineers do that, but eventually do pieces of that on its own. And really the reason it's so hard to find and fix issues is because we have insufficient data immediately at our access. And then we also have insufficient analysis on that data. Because once you have the data, there's too much of it. Can't look at all of it. You need that analysis to be able to get something from it. And so when I talk to leaders about how they're thinking about data as infrastructure, data as a tool, where are they in their kind of transformation of their data for manufacturing, they all agree that it's really valuable. That nobody disagrees with that. None of them feel, well, a couple, okay, so a few, but none of them really feel like they're getting the most value out of the data. They don't know how. They know that there's something in there. They have belief that there's needles in those haystacks. They don't know how to go get it. And so here we present our kind of data infrastructure maturity scale. And I hope you will follow along and maybe ask yourself, where is my organization in this stack up? So most organizations are at level 0. There's no shame in it. That's where we're coming from. We shared that statistic before, which is they're very reliant on reports from the factory. So they get daily reports, maybe they get it once a week. They don't have a live plug-in to their actual data feeds. And this is more common, particularly when you're using a manufacturing partner versus having your own manufacturing facilities. Generally, we see the next kind of spot, most if the folks that are like a little further ahead are somewhere between 0 and 1, they have access to all of the test data, some parametric data coming off their line, but it's often not real time. So they're not fully in level 1. You gotta be at real time access. They're still doing manual uploads. There's still thumb drives running around a line. If there's thumb drives on the line, you're not at level 1. And then there's a few folks that we know who have moved kind of once they get that database of data, they're starting to get some dashboards up. They're plugging it into Power BI or Looker to get these kind of analysis of the meta of what's going on. But the core gap at level 2 is generally they don't have it for the entire team. And that's super important because Jill, who's working over in quality, if she doesn't have access to the data set and it's just one person in the company who's like hooked it up to Tableau, then Jill can't use that data to make the product better. And that's the core piece around needing this access to be available to the entire engineering and operations teams that are actually making the decisions to work on about how to improve the products. And then the final level here is optimizing. This is when you're actually using the data to close those loops. It's doing smart things with the data. So that could be finding anomalies, alarms and alert detection, other correlations from that data. One of the things Instrumental does is we take customers from any of level 0, 1, or 2, and we get them to 3 in weeks. And that is really the mission of our company. So for those who know about Instrumental, you might first think of vision. And it's true. Our first product was a vision product. We build best in the world algorithms for identifying anomalies and visual data from the factory line. But I think if that's all you think we do, I'm going to update you a little bit. You're a little behind. About 2 years ago, we had customers come to us and say, we need more data. We have all of this other data on our lines we can't get access to. And we need our entire teams to have access to the functional test, to have access to these measurements and other core pieces of product data. And so we built that product. We call it data streams. We can take in their data and it's available on the Instrumental platform. They can combine that with data and images. And since we've released that product in this first 18 months of being live, we've collected over 100 million data points. It's included in 50% of the new deployments that we do. So it's high adoption rate of really wanting this infrastructure-wide view of their data. And then it's our go-to selection for the customers we work with who have multi-site or multi-program engagements. They really want to look at all the data that they possibly can from the products that they're building. And so with that, I'm really excited to introduce and launch for the first time a new product, which is called Instrumental Correlations, and it is available today. We actually have customers already using it. I'm really excited to share this product. So Instrumental Correlations builds on the foundation of data streams. When I have all this different data, I need help doing the analysis. And so what Correlations does is it actually is AI that helps to identify useful relationships between your parametric data, so the test results, things about the units themselves, to each other. And that's useful because you can actually use it to find root cause. And I'll show you that in a second. And then what we've also seen is there's this amazing magic when you combine the images and the data together, and you can actually do mixed type correlations to also identify a different set of root causes. And this is so exciting because it's really what I wanted as an engineer is if we have all the data, just tell me why it's broken. And that's what we're doing with Instrumental Correlations. So we're going to play a little video here to show a quick demo. Seeing is believing. So here we're looking at a microphone test, and there's a group of failures that are selected. So these are low performance failures. And I'm able to actually go over and select the final test to see if the failures at the microphone are correlated to anything else in my functional test data. These first couple at the top are related to the microphone itself. So the rest of the test, it's a frequency response. There's a couple of tests that are very correlated. That makes sense. But there's two things that are very interesting that come right to the top. One is the firmware version seems to be a strong relationship to failure, as well as the tester itself. So which individual tester is actually running these units. So that's very interesting. I can also pop over to these image correlations and see if there's any root causes in the images I can see. And so it looks like some subset here, I'm automatically finding a heat map of where the defects are. And the AI is showing me that some subset of these units also look like they have plugged microphone ports. And so the magic of this, you saw this happen. This is not a sped up video, it's a regular video. And it's showing you that you can take your functional test results and actually find core root cause in both your data and your images. And so I'd love to share about how customers are actually using correlations today to actually solve core business problems. So the first example here is from a Fortune 50 company where they actually were able to use antenna results. So they had antenna failures. Many of us have antennas in our product, and they were able to identify 3 different potential root causes based on correlation. So instead of multiple weeks of failure analysis, this happened in minutes. The algorithms were able to rank these very highly. So we have feed screw length. There's a DOE they were running. They actually were able to see the angle of the coax connector mattered a lot. This was something that had no spec on. So this is a very interesting discovery, would have been very hard to find with physical FA. And then they also were able to see there was a small color difference in the color difference was relating and correlating to the failures as well. And while color doesn't impact antenna, in this case, that was correlated to vendor. So super, super useful. Second quick example, Fortune 50 company is working on building wafers with dies on them with special circuitry. So very small. We got these images via an imaging partner, Keyence. And the core problem was they had all these little cosmetic defects like debris and various damage. And they had no idea what actually correlated to functional failures, which for them would be power running through the system. And they actually found and were able to correlate exactly which ones did. And at what level of damage does it correlate to an actual functional failure? And the team there said this saved them 5 months of failure analysis. They were able to do this in a couple of minutes. So really big success from being able to pull this data together as infrastructure. And so as I think back to when we started building correlations and the conversations we had with customers, test engineer leads, VPs of manufacturing, VPs of engineering about this product, when we showed them our early results from our machine learning lab, and you'll get to meet Rustam later if you want to, he'll be in one of the breakouts. We started to see them recast in real time how they talked about data in their organizations. No more was it data, I need tests here, I have this application. It was data as infrastructure and how they're thinking about data overall in their organizations and how they can get value out of that data. And ultimately, it was that inspired today's theme for data as infrastructure at Build Better 2022. And we just really want to thank our early correlations partners and beta testers who've been using this product and giving us great feedback. And if you're interested in this product, we'll be sharing more about it in our breakout later today. So without further ado, I'm so excited that everyone is here and was able to come join us. There's so much great talk that we're going to have today about various pieces of this data as infrastructure theme. I'm really excited about how the world's most reliable product teams use data and learning about that. We've got some other great events for later today, and I'm going to kick it back to Tobias. So thank you, everyone.